Section 6.1, Law of Sines. So we have a triangle that is not a right triangle. For the past two chapters, we've only been doing right triangle trigonometry. Every single triangle we had was a right triangle. Now we have a not right triangle. However, we can use trigonometry on triangles that are not right. So what we're going to do is we're going to use this triangle here and we're going to derive the formula for law of sines, and then we can use it from there. And our second set of notes will derive the formula for law of cosines from a not right triangle. You guys know what it's called if it's a not right triangle? I probably should have been saying that the whole time. Everybody know what it's called? What'd you say? Don't know? You do know? You don't know? What's one of them? Oh, well, scalene could be a right triangle. Obtuse, that would be specifically one that has over 90 degrees. That's not right. It doesn't mean it's not right, but it means something different. It starts with an O. It's called oblique. You ever heard of oblique? Okay. All right, so this triangle ABC, I just drew, what did I draw? What's it called? The altitude or the height. And after I drew the altitude, I can use right triangle trigonometry to set up some ratios. I could say that, oh, I forgot one thing though. In geometry, typically, if we have angle A, the side that is opposite it, we could call it CB, but a lot of times they'll call it little a, so that you know that angle A and little a are opposite each other. And so opposite of angle B would be little b. Again, we could call it AC, but they've simplified the process. And then the bottom one that it's sitting on the base, that would be little c, because it's opposite of angle C. Now, if I want to set up something with angle A, I could say that the sine of angle A is equal to the altitude, the height, over the hypotenuse of just that smaller triangle B. Especially if we gave this point down here a letter, we'll call it D. So that smaller triangle would be triangle ACD. I could also say that the sine at angle B is H over A. Because H is the same for both smaller triangles, I'm going to solve both of these for H. Because H is equivalent in both of the triangles, I know that B sine angle A is equivalent to A sine angle B. Substitution. Now, if I take both sides of the equation that I have and I divide both sides by B, and I'm going to divide both sides by A, the A's on one side, the B's on the other side are going to cross out, and we will get our law of sines that says sine of angle A divided by side A is equivalent to sine angle B divided by sine B. And then one more thing, there is a third side in angle. In order to get the third side in angle, which I'm not going to do, all I would need to do is just like rotate this triangle so it was facing a different way. This is not drawn to scale, but like C would be here, B would be here, A would be here. And then my altitude would probably actually be outside of the triangle, but I'm just going to pretend it's here. I would do the same process but it's going to equal the same way that sine of angle C divided by C is equivalent to the other two. So that's law of sines. It is given below. You'll see it below. It can also be written. We could use the reciprocal property of equality that says if I just reciprocate both sides of the equation or all three sides, then it's equivalent. So it could be written that way too. I don't care which way you use it. So now let's use it. There's two good things about, I guess, this section. One good thing is you will have to use your calculator. And I know some of you love to use the calculator. So go ahead and get that calculator out. The other good thing, as of today at least, is that since these are more like real life examples, the angles are going to be in degrees. However, I don't know. I'm kind of like radians more now that I've used them a lot. Does anybody else feel that way? They're easier. Don't know. Indecisive stuff. Okay. So check your calculator and make sure it's in degree mode. All right. Nope. Trying to set it up so we can see both at the same time. That's good. All right, we have to solve for all the remaining angles and sides. So let's look at the triangle. What can we easily find first? What can we easily find first? Oh my gosh. We can't spend all day waiting for somebody to yell out an answer. Let's go through these notes. What can we find first? Angle A. So let's do the measure of angle A. We're going to use a theorem from geometry, the triangle sum theorem. 180 degrees. Take away the other two given triangles. Given angles. And we're going to get that measure of angle A. So we can just, use our calculator. This is going to be a calculator section. Go, measure of angle A. This is too small. I'm just going to have to go back and forth. All right, now we need to find side A and side C. So I didn't mention this yet. The example that we are doing is AAS. Do you guys remember? Side, 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 angle, side. You can use law of sines if you have angle, angle, side. So I have two angles and a side that is not included between those two angles. What I do have, this is what I look for more than angle, angle, side. This is what I look for more is, do I have one side and the opposite angle? If I have one side and the opposite angle, I can use law of sines because when I set it up, sine of angle B over side B, I can use that to cross multiply and solve any of the other ratios. So let's see, I need A. So we'll do sine of angle A, which is 49 degrees, and I'll divide that by little a, which I don't know. So I'm going to cross multiply. And I'm going to get 27.4 times sine 49 divided by sine 28.7. Remember, if you have the newer calculators, alpha y equals will make it a little bit easier because then you can get fractions. If you do not have the newer calculator, you can still do this. Oops. I hope that every single person in here is doing it on their calculator to make sure that you get the exact same answer that I get, and that we don't find out later I'm doing it wrong on my calculator. Does my answer seem reasonable? Did anybody else get my same answer, or am I the only person that got that? I see faces, and then or at least I see your eyes, and then I don't know if you guys have a question or if I have something wrong. Like I can't read your faces. So it's approximately, it doesn't really say what to round to, so we'll just do 3 decimals. I like 3 decimals. It doesn't say right now what to round to. If it's something like a test or a quiz, definitely will tell you what to round to. If it's a Canvas quiz where you have to put your homework in, I'll definitely say what to round to so all the answers match. What? Okay. All right, now we are going to use the same original sine 28.7 over 27.4. I'm going to use that again because I know that is for sure. I didn't make any silly mistakes because that was the information given to me. I don't always trust that I wouldn't use angle A because I don't always trust that I didn't make a mistake on it because I make silly mistakes all the time, as you all know. So I'm going to use the one that was for sure given to me, and then we're going to do the sine of 102.3 divided by little c. Cross multiply. Got 55.747. I just want to kind of look at that and say, does that seem reasonable? It's the longest side. Was it across from the longest angle? Does it seem reasonable? Just make sure I didn't make any silly mistakes. And that is law of sines. Bring back any memories? Hopefully good memories. This next one is angle side angle. So ASA, here we've got 43 degrees. Then we have 22 feet. And then once you read this, what's happening here is this, what kind of pole is this? It's a pole, whatever pole, this random pole sticking in the ground. It was right, but then it's leaning 8 more degrees. So basically this is a 98 degree angle. So we've got angle side angle, and it asks, how tall is the pole? What is our A value? So according to 43 degrees, A would be opposite. So I could do sine 43 degrees over A, but I'm solving for A. So I need an angle and the side opposite it. The problem is the angle I have, I don't know what B is. Like, I don't have side B. Somebody's speaking, and it's good. I can find angle C because I know two angles in the triangle. Use your triangle sum property theorem. 180 degrees minus 98 degrees minus 43 degrees. What is angle C? 39? Yeah. Okay. All right, so now I can do sine of 39 degrees over 22 feet. Cross multiply. Let me get the pole. Oops. The pole is approximately 23.842 feet. Now I think about, does that seem reasonable? If the pole was 90 degrees, this would be meh. If it was 90 degrees, if that bottom was 45, this is pretty close to a right isosceles. It's pretty close to it. So having an answer that's pretty close to the 22, I think seems reasonable. Did that make sense where I was going with that? Okay. I see it in my head. All right. Now, this, I do not know if you covered in geometry or not. This is the ambiguous case. And remember in geometry, when you guys were proving, and they said, what happens if you get ASS? You can't use it to prove two triangles congruent. And that's because there's not enough information. Oh, I had this up earlier, and of course, everything was crashing. Let me find it. There's an animation that I have, or that I found. It's this one right here. There's probably others that do the same thing that I'm trying to do. Okay, so this one I know does it. Can you see how in this triangle, we've got, I wonder if I can, see if I can snip it. I don't know if I can. Oh, it's too slow. I can't do it. One more try. Oh, I got one of them. Yes. Okay. I was trying to get it when it like lines up with the very edge. Okay. Did you guys see it moving? I can go back to the movement part. I just want to show. I'll just put it right here. Okay. We're going to look at two different triangles here. We've got triangle ABC. And then you guys saw that swinging, that one, that BC is swinging. So BC could actually be BD instead. If it's at BD, this would be the triangle. I do know for sure that BC, because you just saw it swinging, and BD are equivalent. They're the same length. Okay, so if we have angle, and then we have side, and then we have side, or if we have angle, side, side, you don't know which one we have. There's two possibilities there. So we're going to come back to this picture in a moment. What I have here is, if you're given information and it is angle side-side or side-side angle, you have what's called the ambiguous case. And there are 6 different scenarios that could possibly happen by the information that you're given. So we need to process through this and figure out which case you have and solve accordingly. If we're given, and every single one of these talks about angle A. Okay, angle A is just whatever the angle is. In here, it's also angle A, but I bet you I could draw a triangle that doesn't have an angle A in it at all. Does anybody know which angle right now is the angle A? You do not know because angle A has to have specific information to be able to tell. So you do not know. In order for it to be angle A, well, it's going to be the one that's given. So I haven't given you any information. So we'll say it's this one right here. Now it kind of looks like the picture. You also have to, and that'll be my angle. You also have to have the side next to it and then the side opposite it. So once you have that information, now we have that ambiguous case. Okay. So going back to this, if angle A is acute, there's 4 different scenarios we could possibly have. If angle A is acute, let's look at this scenario right here. If the side A is greater than side B, if the opposite of angle A is bigger than the side next to angle A, you will only have one triangle. It can only happen that way once. If side A is less than side B, we have to find the height of the triangle to be able to determine if there's 2 triangles or 1 triangle or no triangles. So to find the height, we just did that when we were deriving the equation. Here's the height formula. Height equals B sine A. That was from when we derived the law of sines in the first place. So once you find the height, then you're going to compare the height to side A and determine, do we have no triangle at all? Could it be 1 triangle? Could it be 1 triangle? Could it be 2 triangles? If A is obtuse, then we just compare A to B, and you either have no triangle or 1 triangle. So if A is obtuse, you won't have 2 triangles. So really the ambiguous case would be, do we actually have a triangle? Is there 1 triangle or is there 2 triangles? Now the notes that, this is just screenshotted from the book, they actually tell you how many solutions you have, but we'll pretend we didn't read the title of the notes. And we look at this triangle and we say, all right, I've got an angle and I have the side across from it. And then I have the side next to it. Uh-oh, that's a word I shouldn't say. I've got the ambiguous case. So I need to start looking at my side A, my side B. So I look at my A and I look at my side B. Oh, and I also have to determine that A is acute. So A is acute. Then I'm going to look at side A and B, and we determine that A is greater than B, and they wrote that right here. A is greater than B. So if A is greater than B, out of the 4 acute scenarios, one of them already says A is greater than B. So we have 1 triangle. We just proceed on with law of sines the way we normally would. Sine of 42 degrees over 22 inches is equal to sine of angle B over 12 inches. Find the remaining sides and angles. So when we have 1 angle, we have to find another angle first. We're going to cross multiply. And once I've cross multiplied, I do not have B by itself. So we have to inverse sine both sides of the equation so that we can actually find angle B. So I'm going to type into my calculator sine inverse. Then we get 21.406. Determine if that seems reasonable. I think it seems reasonable. It's got to be smaller than the 42 because the side across from it is smaller. So what could we find next? What do we have to find next? Angle C, measurement of angle C. We just used our triangle sum theorem, 180 degrees. Now here's what I want to talk to you guys about. We're going to talk about accuracy. We don't want to subtract 21.406. We want to do our 180 degrees, and we want to subtract the whole last answer. We want the entire thing, not just a rounded version. And then what else? So 42. And again, the next step that we're going to do, we don't want to use a rounded version. We want to use the whole thing. I know some of us have older calculators in here. What I'm about to teach you is very helpful for older calculators, but it is also helpful for when you are doing way more complicated stuff with the calculators where you need like 4 different crazy decimals at a time and you don't want to have to keep up and grabbing things like if you have the newer calculators. I'm going to go over just storing the value so we could bring it back using alpha. So actually I'm going to use C to store it. But to store it, there's this button. I don't know if you can see my little mouse moving. It says STO and then there's an arrow. It's just the regular button right above on. If you hit that, it's going to say, all right, I'll take that last answer. And where would you like me to store it? And you have to hit alpha. And I'm going to put it in C because that's the angle. So to me, I'll remember where I put it. Enter. And now it says, okay, it's stored. It's done. So now if I ever want angle C in the future, I just have to type in C. I don't have to type in the numbers. I don't have to go up and grab it. I just have to use the actual letter C. So what do we want to do? We want to solve for, what are we solving for? Angle C. So we'll do sine 42 degrees over 22 is equal to the sine of angle C, which I just stored, over little c. And cross multiply that. So on my calculator, I can do 22 sine alpha and then get the c divided by sine 42. So this is one where, do I really need to store it? Probably not, but I wanted to show you how to do it because it becomes more useful when we need that value repeated multiple times. Anybody need to ask anything? No, we're good. All right. So they've already told us the answer. There is no solution, but let's figure out how we would have done it on our own. Show that there is no triangle for which little a is 15, little b is 25, and angle A is 85 degrees. So it doesn't really matter what letters we're using. You just need to know that the side and the angle across from each other are going to have the same letter. And so next to it would be the other side. So when I'm looking at my A, which is across from my A angle, and I'm looking at my B, I can determine that A is less than B. And we have an acute. I always forget to say that part of acute. So I'm going to go back up there. A is less than B. So I know it's not A is greater than B. It could be 2, or it could be none, or it could be 1, because that says nothing about the B's on those first 2. So I need the H value to figure this out. So we're going to find H, which is B sine A. So we do 25 sine 15, nope, 85. We get 24.905. So I see that A is less than H. So I'm going to go back up there. A is less than H is the very first situation where it says that can't be a triangle. So this right here is telling us why. All right, so we've done one triangle. We've done no triangle. Guess what's next? 2 of them. There's nothing in this sentence here that tells me which triangle it is, so we got to find both. Okay? You ready? All right. So what I'm going to do, I'm going to stay organized, and I know what's going to be written down, so I am going to divide this paper in half, and I'm going to have the 2 triangles on either side. Probably figure out why we have 2 triangles in the first place, though. Find the 2 triangles for which A equals 12 meters, B is 31 meters, and angle A is 20.5. Remember that thing I copy and pasted? Do it again here. I just don't have a ton of space, so try to sneak it in here. Okay, so our first scenario, we are going to look at this triangle. So it says A is 12, so there's my 12 meters. B is 31, and guess what? It's not literally B in the picture. It's actually D in the picture. So it's not really telling you the angle letter. It's telling you that those are the 2 sides, and then the angle, it does happen to also be angle A in the picture, but it's the one that's across from side A. So 20.5 degrees. Okay. So we're just going to solve number 1. What can we find first? Does it bother you the thing in the middle is there? Does it bother you? What do we do about that? I forget how to pick other. Oh, here it is. This colorish. Nope, that's not black. Try that again. Oh yeah, now it looks like it's not really there. I do want to look at that later though. That's the triangle we're looking at now, okay? What do we got to find first? Angle what? D? Okay. Oh, so I'm going to have to use law of sines because we don't know the other angle. So we're going to do sine of 20.5 divided by 12 is equal to sine of angle D divided by 31. Oh gosh, we didn't even talk about why there's two answers. I'm sorry. We need to talk about that still. I was too busy drawing the picture. I got distracted. In this picture, we have the side A is less than the side B. 12 is less than 31. So that means we have to find our H, which is B sine A, which is 31 sine 20.5. Yeah. 31 sine 20.5, which is about 10.85, 10.9, something like that. So where does that fit in with the A and the B? This is 12, this is 31, that's less than A. So we have the scenario where H is the smallest of the three. That tells us we have 2. And that's just coming from this previous page, the different cases. That's telling us 2. Okay, now we can go back to finding the 2. So I'm going to set this up. I'm going to cross multiply. I'm going to get sine D, 31 sine 20.5 divided by 12. I'm going to have to sine inverse that. I think if you are not getting the correct thing on your calculator, this would be a good time to ask rather than wait 25 minutes later and then mention that you never did any of it with us because you didn't have it correct on your calculator. I got 64.783 approximately. Okay, I'll tell you right now that I might use that later. So I'm going to store it. And it's angle D. So I'm going to store it as angle D. We'll hit store alpha D. Enter. So I just stored it as D because I know we're going to use it later. Again, if you have the newer calculators, you can like up and find it, but this is a new skill to learn on the calculator. So it's good to try it this way. All right, so we have angle D. Now we can set up to find what next? Angle D is like 64 point something. I forgot. 783. There we go. What can we find next? What, Gracie? Angle B. Oh, angle B. Mm-hmm. All right, so let's find angle B. And we can just use our triangle sum theorem. Take 180, we're going to subtract off angle D, and we're going to subtract off 20.5. So since I stored it, just want to use it since I stored it anyway. I'll go ahead and type in 180. Why is it not working? 180. Oops. Okay. And then I'll subtract off, and then I do alpha D, and then I subtract off 20.5. And I get the measurement of angle B is 94.717. Is that what you guys got too? Okay. All right. And then we need side AD, which we can call little b in this case. Oopsies. So to do that one, we're going to do sine of 20.5 divided by, I already forgot what it was, 12 equals sine of, well, I guess I could have stored b. Maybe I'll go store that. Divided by little b, which I don't know yet. I'm going to go store D or B so I can use it. Again, you don't have to store these. I'm just practicing with it, so that's why I'm storing it. Cross multiply. We get B is equal to 12 sine capital B over sine 20.5. Oops. That was kind of interesting. All right, we did it. We found half of the answer. Let's find the other half. So in this other one, we don't have D. However, we do need D to find C. We do need angle D to find C. Let's go through the steps. The first thing that we need to do is find the measurement of angle C. That's the first thing we're going to do. Oh, I should probably label these. This is 31 meters. This is 12 meters. And then this angle right here, angle A, is 20.5. Same as it is. And what I'm going to do is I'm basically going to do the exact same thing all the way down. So measurement of angle C is related to D. Let me show you up here where I said I was going to come back to it. It's right here. One more time, right here. Angle D, no matter what the measurement is, it's in an isosceles triangle. C CBD is an isosceles triangle. So tell me about angle C on the inside of CBD. It's going to be the same as angle D. So then what about on the outside of that angle? Supplementary, linear pair, adds up to equal 180. So when we go to find this next version, the only thing we really have to change is the measurement of that angle that we find first. And we do that by subtracting the measurement we found the first time, which I stored as D because I knew we'd have to come back to it. We just have to take 180 degrees and subtract off the measurement of angle D. So since I stored that already on my calculator, I just have to do 180 minus, oops, calculator would work faster, minus alpha D, enter, and there I have it, 115.217. The next thing that we did was find the other angle. We're going to do that the exact same. We're going to use the triangle sum theorem. So this time measurement of angle B is going to be 180 degrees minus C minus 20.5. So like we're doing the exact same stuff for every step. It does go a little bit faster the second time. Especially if you don't have to wait for my slow computer here. There, I didn't store it. I just used answer for that one. 44.283. And then we will find side B. Which for this one would be AC. It's going to be the exact same it was right over there. Sine of 20.5 over 12 equals the sine of angle B that we just got over little b. So we'll cross multiply that. I do want you guys to notice, like, some of them I stored. These, I just used the last answer. You should not be rounding any of these. You should be using the calculator. You shouldn't be rounding them. So I get 23.924. And I think that was meters. All right, the very last part of this section, by the way, law of sines was way longer than law of cosines, just so you know, if you're thinking like, oh, we have to do another section still. Yeah, but this was way longer. The last part of this section is how to find the area of a not right triangle. You do not have to find the height and the base. If you have side angle side, there is a formula that says the area is equal to a half multiplied by side 1 multiplied by side 2 multiplied by the sine of the included angle. I wrote angle between. So this only works for side angle side. Can't use it all the time. You need to have side angle side or get side angle side using other information. For this particular area, we would do 1/2 times 52 times 90 times the sine of 102 degrees, and you'd hit enter on your calculator and you'd be done. Okay. That is it for law of sines.